Very happy to introduce Earl, Joseph, and Jackie Ludema of Hyperion Research. Earl, Jackie, thanks for joining us.
Thanks, Jay. We look forward to having a fun conversation today. We're going to be covering, what do the HPC AI users want from the cloud? And all the work we do when we talk about HPC or AI is under the umbrella of scientific and technical computing. So it does not include the social media side of AI and some of the other aspects of AI. The other thing I should mention is we will soon be doing a press release on some of the market shares that Jacqueline's going to be talking about. So look forward to seeing that in the very near future. For those of you who don't know us, Hyperion Research, we used to be part of IDC. Our group's been around for, I guess it's getting close to 39 years now as an overall group. And what we do is we track the technical computing, scientific computing marketplace. We help organizations make effective decisions. We attempt to track everything sold every quarter by 28 countries. And in all technology areas, we maintain 5-year forecasts, and we do a lot of surveys and studies. We also operate the HPC User Forum, and we always invite everyone to join us. We usually have 2 large US meetings and 1 or 2 international meetings a year, where we bring together the real thought leadership related to HPC, both from the user's perspective and the provider perspective. And with that, I just want to leap into a few background observations and things that's happened recently, and then Jacqueline will dive down into the main topic. So first of all, last year was the strongest growth year that we've seen in over 2 decades. The technical computing or HPC market grew just dramatically. It's now reached $60 billion. Roughly 23% of it growth as far as on the on-prem servers. To put that in perspective, the on-prem servers were growing around 8%, 7 to 8%. So that's where a major shift there. The use of clouds has also spiked tremendously. It's at 21%. Now, looking at the last 5 years, clouds have been growing at a high rate here, 17, 18, 19%. But again, this is, one of the highest growth years from a percentage viewpoint. But also you can see here, cloud is spending in the cloud is already 15% of the overall market spend. And Jacqueline will talk about where we expect that to go in the future. I also want to make sure there's some clarifications on definitions here. The way we track the cloud is what technical computing or computational folks, engineers and that spend in the cloud. So this is not what the cloud providers like Google goes out and buys, systems. This is what end users spend to operate their workloads within a cloud. And now looking just for this year that we're in the middle of right now, we're expecting to see strong growth. We're just finishing our second quarter numbers, which would be the first half of the year. It appears that 2025 could be another higher growth year, even higher than last year. This is heavily driven by all the excitement around AI, all the new capabilities AI can provide, the different ways to use it. But on top of that, this excitement around AI has led to a lot more understanding of where highly computational systems, large data sets, using traditional codes can be useful. So it's kind of bringing both parts of the market into a growth mode. We're also a little bit nervous in the market right now because there are some supply chain issues still. There's some political issues going on around the world, tariffs, and sovereign things. So, we're concerned that those may damper it a little bit. But like I say, for the first half of the year, and we're just finishing that second quarter numbers, it looks like we're in about a 20% and above growth rate. And it could be dramatically higher than that, depending on what the second half of the year looks like. And the big drivers here, as I mentioned, was the AI, the generative AI, agentic AI, and also countries around the world are getting really interested in having their own sovereign technologies, their own large systems. If you look at Europe, they were doing AI factories. Now they're talking about also doing giga AI factories. And in the US, similar thing, where, they were planning to build these AI systems, and now they're planning to build gigantic AI systems. So some real tremendous growth there. Last fall, we announced a new way that we're tracking the market. This yellow bar area here in this chart is really the non-traditional AI supplier. So this is like NVIDIA or Supermicro. They're not a regular on-prem supplier, but they are now selling servers directly or through very small channels. And if you notice, in 2020, didn't make up much influence in the market. And literally in 3-4 years, it's getting on the order of to be 15% of the market or more. The net change here is the magenta line was our forecast from a year ago, and the black line is our new forecast. So just tremendous growth in the market right now. Again, our expectation with AI is once the R&D parts of the world, national labs, but even in companies really understand how to apply AI to do their R&D, we're going to see orders of magnitude faster R&D and more R&D completed in the world. And that's why we're showing such a change in our forecast and a very high growth rate. And with that, I'd like to hand it to Jacqueline.
Thanks, Earl. Hi, my name is Jaclyn Ludema. I'm an analyst with Hyperion Research. I am going to be sharing with you main topic of discussion, really what cloud users, what users want from their cloud experiences. Okay, so first up, we have another look at our global HPC forecast model. So this is our projection for the HPC AI market into the future up to 2029. The total HPC market is projected to experience growth with a 5-year CAGR of 14.1%. Within this chart, the total market is divided into on-premises and in cloud. The cloud market is expected to see a 19.5% overall CAGR. So it started out in 2024 with it is 15% of the market. That is projected to expand to 20.15% of the market by 2029. So both on-premises and cloud are expected to see growth. On-premises, it's going to be a 13% CAGR, and the cloud growth is going to be higher with a 19.5% growth. All right, zooming in to the cloud portion of this for the next slide. We have our cloud forecast. It's broken down into 3 major HPC AI sectors. That's the industry in blue, government in green, and academia in purple. As you can see, the industry that's in blue is the largest sector overall. However, it's very interesting to note that the academia sector has the highest CAGR and growth rate by far, with a 30.8% CAGR here. So while it's by far the smallest sector, cloud is projected to grow substantially among academic institutions. This is due to several factors, including academia venturing into AI in more meaningful ways, but also open science programs that are encouraging collaboration among both large and small academic institutions. So that's very cool, in my opinion, to see smaller academic institutions, they're being provided access to HPC and AI through access in the cloud. All right, this next slide, this takes a look at our historic data. We have the cloud service providers' shares of the HPC market. And while AWS is maintaining the leader share, hovering between 43 and 48% of the total market. The more interesting story is in the smaller market shares. Around 2023, we saw Azure, which was the 2nd largest, and Google, which was the 3rd largest. We saw them switch places in rank. So Google is now approaching the 20% mark on total market share. Another interesting observation of this chart is the other category that is in 2024 was about 14% of the market. The other category is expanding due to, in part due to the concept of Neoclouds. Neoclouds aim to bring specialized services for AI. They sometimes provide access to advanced technology alongside custom platforms, and they're all designed to get users up and running on AI faster and more efficiently, is what they project.
And Jacqueline, I might add too, is because of the political pressures in the world, we're not really showing the Chinese providers here. So I just want to let everyone know that there's a little bit of it here, but these are people outside of China using Chinese providers. It's not the Chinese providers servicing China and Greater Asia. Just want to add that note.
Yeah, thanks. Great point. Okay, so On to user motivations and perceptions about cloud. So in several of our most recent cloud studies, we've asked respondents to tell us what's driving them to use cloud for their HPC and AI workloads. And the majority of respondents have many different reasons for choosing cloud. So they have cited access to latest GPUs, the ability to dynamically and quickly add or remove resources, access to new methodologies, the ability to do things the ability to try new things have been cited most frequently. In recent studies, we've also asked them, began asking people to rank these factors. So the question is on top here. On a scale of 1 to 5, with 1 being the least impactful and 5 being the most impactful, please indicate the impact. And I'm representing that in this chart with the varying levels of gold. So when we're looking at it this way and considering 5s and 4s as the most impactful, we're seeing that the ability to get to do things that couldn't be done before is ranked as the most important. And then we have the ability to run jobs at larger scale and then access to latest GPUs. In the constant race for the latest technology to establish competitive edge, access to the latest GPUs in cloud, the latest GPUs which are available on cloud far earlier than many on-premises groups is definitely a motivation for cloud users. All right, so on to customer perceptions. So we regularly ask customers who are using cloud or on premises their perception of where, how they compete, how on premises and cloud, where they excel. So this chart needs a little bit of explanation. Each of the bars represents the entire respondent pool, and we ask them each individual areas where they see on-premises or cloud winning out. So the yellow to the right is is where users perceive the cloud to be better than on-premises, and to the left is where they perceive on-premises to be better than in the cloud. So we're finding, and a little bit more explanation, the darker gold is where people say they are far exceeding. They say cloud is performing much better than on-premises. Yellow is slightly on the opposite side, is the same for light blue and dark blue. So at the top here, the perception that access to the latest LLMs, GPUs, and software stacks, all these cutting edge methodologies, is really a perception, whether you're using cloud or not, is they believe that's where cloud is outcompeting on premises. There's also the concept of open data access. This is, for example, with genomics and the omics research, the ability to share those huge data pools is where cloud is exceeding as well. That access and those playgrounds where more researchers can come and they don't have to have that data on premises. There's a sharing mentality throughout that entire community. That is another place where the perception of cloud is really far greater than on premises. All right, and we also ask the same groups of people about barriers for accessing cloud. So we ask that same question where people are able to rank on a scale of 1 to 5 if these barriers are influential to why they are not able to do more HPC or AI in the cloud. So again, in the same, just like the drivers in barriers, there are multiple barriers that people are selecting. Most respondents selected several of them, whether it's a huge impact or not, they're selecting them. And for this, we have the cloud costs are perceived to be too high. That is the most impactful, with the most 4s and 5s selected. And then another interesting side of this is the number 2 most selected for the most impactful barrier is the difficulty in migrating applications from on-premise to cloud. And then the third one aligns with the perceptions of data locality and access speed. There are some workloads where your data locality is key, and that is going to be what prevents you from adopting more cloud if they're not willing to move or share their data with their on-premises environment. All right, and this is one of our most recent data points. We had a top-of-mind study where we sent this out to as many respondents as we could, asking them for a very quick survey, and we asked them, in what areas do major cloud service providers need the most improvement? We asked them to select up to 2, and again, in this study, we found that the main concern was cost. Cost of storage and cost of compute. That is still a perceived area where cloud could improve. But interestingly, when we took a deeper dive into this data, we found that those 2 top ones, the cost of storage and the cost of compute, were only selected together by about 15% of the respondents. The majority of respondents here were more likely to have a mixed bag of what they view as areas of improvement. So the better on-premises cloud, on-premises/cloud integration, the increased capabilities and transparencies for sovereignty, those were selected alongside one of those cost computes more frequently. So it really is, there's no one size fits all solution. There are plenty of opinions, and I thought most interestingly in this data was the fact that 13% were interested in a write-in. They selected something, and then their second write-in was an other. That included better cost overrun guardrails. We've heard a lot about guardrails and the need for them, and the hesitation of some customers not being able to use the cloud because they're afraid of overspending. They're afraid of accidentally letting something run and then having a huge bill in the morning. So a write-in for guardrails, that was very interesting. Faster, easier cloud formation and cross-cloud flexibility, more integrated HPC secure encryption. So this person wanted the other section because they had more to say than just 2 options. They said more integrated HPC, secure encryption, cloud storage, and on-premises solutions. And then there's also the sentiment of more transparency and considerations for sustainability. I'll dive into those a little bit deeper in a couple other slides. All right, so another recent study that we had, we're jumping to, the next few slides are jumping into the surge of AI. So these are AI specific questions, AI in the cloud specific questions. So this is the envisioned advantage. This is another perception question, but just for AI. And the most prevalent advantages, were faster time to solution. 56% of respondents were able to select all that apply, but 56% of all respondents in this study said faster time to solution was really a driver for them using cloud for their AI exploration. New insights and knowledge, that was selected at 55%. Computational efficiency, fidelity, time to solution, all scored very high. And there was also the note that 4.3% of respondents selected, respondents selected an average of 4.3 select all that apply. So there's definitely a understanding that there are many different reasons for moving to cloud for their AI workloads. I'm having a little bit of trouble. There we go. Okay. So for this next one, this is cloud-based AI workload stages. We asked for in terms of runtime, both both in the conducting AI stages and their overall cloud workloads. How much of these are taking up their workload commitments? So the first one was LLM training. The second one was the fine tuning, depending on your sector or company specifics. Then there's inferencing, verification and validation, and other. So when it comes to conducting AI stages, in the AI stages of your workloads, the generative LLM training took up 98%, and the sector and fine tuning 95% of respondents selected that. So for sites conducting generative or LLM training and fine tuning, these two AI types consumed an average of 60% of the total cloud-based AI workloads. Okay. All right, so this is another perception question. We are asking more about the impact AI has on a HPC cloud strategy, whether their AI-based models, we are using the cloud-based AI efforts, experimentation, and production on the upswing. So we are seeing that 58% of respondents are using AI-based models for experimentation. They are using more AI-based models in the cloud for experimentation. That is a key point we've seen across several of our studies, that they are coming to cloud because they're not exactly sure what they're doing, what their plans are for AI. They just know that they need to get into the experimental phase and discover where AI is really going to be applicable within their larger HPC workloads. So we are seeing little evidence of any decrease in AI-related cloud usage. They are here. They're ready to explore in the cloud for experimentation. All right. Within this study, we also asked if there's a total annual spend for cloud-based AI activities. Really, the answer here is that there was no preferred budget. They are ranking somewhere in the middle here, with the most being at 25,000 to less than 50,000 at 13%. But obviously, the rest of them are very closely close to a tie here. So 57% are spending less than $1 million. This also points to the experimentation phase of things. They are looking to see where it's applicable and where it's not working out. 23% of spend is between $1 million and $10 million, and 10% do not track cloud spending on AI activities. Okay, so we also asked users on their start date for cloud-based AI workloads. When we were asking people, so have you started? When did you start? Or is it still in the plans to start? And the majority of respondents say that they already have some form of AI-based HPC efforts going on within at least 1 year, for at least 1 year. So they are already here. They are in the last 13 to 18 months at 39%, and in the last 7 to 12 months at 21%. Only 11% plan on waiting 6 months or more. This is really indicative of the idea that those planning on using AI have already made that jump. They have already made that jump into whether they plan on doing more. That was in a couple slides previous, but the users that are interested in experimenting with AI workloads in the cloud have already at least dipped their feet in. There are very few people who are waiting for something big. The benefits and the reasons for using cloud are already apparent to them, and so they've already made that leap. Okay, and alongside with this, we also asked those same that same group to tell us which CSPs they are using for AI and HPC. This is the first table is, sorry, the first graph here is for them to select all that apply. So we see that AWS is being used at 61%. Google's right behind them at 50% of total users, and Azure at 47%. So the idea is that users are in that experimentation phase. That 60% of them are in the experimentation phase, and they are not just sticking with one CSP. They are in general handling the average is 2.2 cloud service providers per respondent. So they are not limiting themselves to just one CSP for where they are trying to find a viable AI workload or AI use in their workloads. All right, and then this last one here is the primary cloud provider. So we're asking them, what do they use the most? And AWS is at 33%, Google is at 23%, and Azure at 22%. So 96% committed at least half of their funds to a single CSP. And I see the wow face from Jay. That is a very interesting. They are finding a home in one of these and performing, as well as playing the field and figuring out which cloud service provider is applicable. All right, so I threw a lot of data at you, and I just wanted to try to summarize what we had here. The key takeaways: we have cloud-based HPC AI. It's surging, 19.5%, 19.5% CAGR to $23 billion by 2029. Industry, government, academia are all accelerating in adoption. Academia is up at 30% there, really taking those leaps because of excellent open science programs, as well as smaller academic groups wanting to take a leap into AI and in a very new meaningful ways. AI is the growth engine for sure. We are seeing AI and generative AI and LLM fine-tuning dominating workloads, consuming about 60% of runtime. And the experimentation is widespread. It's 58% of AI models are used for experimentation, 49% for production research. Users are trying to find where AI can be helpful. That exploration process is very interesting, and the cloud is a great place for experimentation because of the ability to bring in new resources, or dynamically change up the resources that they're using, and the ability to scale up their workloads once they find something that's actually working. All right, so what customers need from cloud providers at this time? Customers, based on the data we've had over the last year and beyond, customers really want more than just infrastructure. They are looking for strategic partnerships, clarity, and tailored support. They are really looking for that cost transparency and control. There are still plenty of hesitation. There's plenty of hesitation jumping into the cloud because a lack of expertise in the cost management there. That's why perception of high cost and really its unpredictability of their pricing is cited as the top inhibitor. Some people are just terrified of getting that that extra bill they weren't anticipating because they didn't optimize. They didn't have a full clear understanding of pricing in the cloud. So they're also looking for seamless migration and integration. Users struggle with their app migration, and they might not know where to start because of that. They want better on-prem and cloud interoperability. They have their own reasons why they might not want certain workloads in the cloud, and they want this ability to interoperate to be better spelled out for them. They are also looking for domain-specific expertise and support. Right now, on-premises still wins on technical support, and that's mainly because the on-premises they know the workloads. There's a bit of hesitation there to jump to a cloud provider if they don't think that they know the same ins and outs technical support-wise, especially for domain-specific software. And so, yeah, there's some hesitation there. However, there are many new customers coming to cloud to explore AI. So this is my hot take, the biggest take here, because they are taking that leap right now for AI, the time to showcase cloud support and all of this, all of the support that we have heard about, the domain-specific specifications. The time to showcase that to your customers are when they're already there. They've already taken that leap into the cloud for AI. Show them that you're there to support their domain-specific software. Do it now. And yeah, there's also still this security, sovereignty, and sustainability concerns. Those exist. Those exist. They're very important. The data locality is becoming more important for the European group, the European market, for example. Environmental impacts. For some, there is a sense that on-premises, at least they have control over their environmental impact. They know what's happening. They know what's happening there, and they might feel like they have more control over their environmental impact. Explaining to them the great strides that the large cloud service providers, including Google, are making in their environmental sustainability goals is, I think, a key thing here. Okay, so what CSPs should do now? They should simplify their onboarding. Don't make it so scary for new users to come in, invest. They want templates, they want frameworks, they want migration tools for scientific engineering domains. Some of these people are scientific domain-specific scientists, have onboarding to make that make it easier than on-premises, if that's possible. Make pricing models easier for onboarding. Offer those guardrails. Guardrails are, I keep hearing that throughout our studies, that if there was, bumpers on the bumpers while bowling, people would bowl more often. Those guardrails make people feel secure, the predictability, or even flexibility on pricing. There might be some issues with onboarding where moving data into the cloud, that data movement might be cost prohibitive. Adding flexibility in your pricing would be a great idea. Strengthening hybrid capabilities. Again, there are many reasons why hybrid capabilities are key for some users, and the interest in exploring uses for AI. There might be some people looking to leap to cloud to see if that works, but just for their AI practices. Strengthen that those hybrid capabilities. And then lead on sustainability, address power demands and environmental impacts with transparent metrics and innovations. The amount of users who are concerned and even looking to change, looking to see how they compare with their on-premises capabilities. They need those metrics. They need those that transparent metric to do those comparisons and possibly make that leap. Okay, Earl, did you want to? This was your slide. I'll have you jump over there.
Sure, thanks, Jacqueline. So our next study that we've just finished, and we're just doing the final write-up and analysis, is we're looking at what is the return on investment for AI and technical computing. There's been some reports in the media about how many enterprise AI jobs have failed, as far as meeting the objectives and goals. Where we're tracking success stories in HPC, we have over 170 already, and it's growing very quickly. And we're trying to better understand what is the real return on investment, what's needed, because very clearly in the technical computing, scientific computing realm, AI seems to be feeling much more successful than in the broader enterprise space at the moment. We're looking at kind of how those budgets are changing, because if you're successful and the ROI looks good, you tend to have more budget coming your way. And we're definitely seeing that, I should mention too. And then what are the metrics different organizations are using? We do a lot of research on what's the value of R&D, and so what is the value of a successful AI model in the technical computing world? So we're working very hard to better understand that, measure it, and describe that. And in summary, I want to mention a few things. We've shown our forecast for cloud computing, and you've probably heard us say this many times. We're expecting there's going to be another tipping point. And by tipping point, I mean a much higher growth than we're actually showing right now. One of them is all those success stories I mentioned that we're looking at and everything. But also the whole issue of training. And NVIDIA brought up this earlier this year, that training is going to take 100-fold the computational power. We think that once AI is working in R&D, and what I mean by that is not just technically working and functionally, but where scientists and engineers are accepted and you start using it in a big way, you could see orders of magnitude more computational work going just for scientific computing. Because one thing about scientific computing, sites have always wanted to do more work than what they had on-prem. And they always wanted to do more job runs, more science. And so if they can show the ROI and success stories, we think that's going to grow quickly. We're also seeing an uptick in small language models. And by small language models, they're much more targeted data sets. Their model is designed for an organization, perhaps having a little bit more control over the model itself too, so that the transparency certification issues that Jacqueline mentioned that are, holding a lot of folks back, how can you really trust the result question is there. So, just in summary, we're expecting to see another tipping point for a whole set of factors that we've already been talking about that. And with that, I'll hand it back to Jay.
All right, thank you guys very much. That was a lot of great information, and I know I have some questions already, and we will also take questions from the audience as well. In fact, I'll start with that. Let me jump into that and ask a question from the audience. So you said how big, Sudhanshu Jain asks, how big is the HPC business for GCP in 2024, 2025? Sudhanshu, if you are at Google, email me and I'll tell you what our internal numbers are. And Earl and Jackie can say what their measured numbers are. And Sudhanshu, I can also explain to you why these numbers might also be somewhat different and what the rules are on reporting according to Sarbanes-Oxley and things like that. But Earl, do you have a off-the-cuff approximation for what, using your share percentage for GCP and the cloud market, what the Google share is for scientific and technical computing?
Jacqueline, could you, or Jay, could you show the chart with the market shares? Because I think it's good to show that one. I don't know if we're able to go backwards in the slide deck, or is that possible?
Mary, can you pull that back up and we'll go back to look at that slide?
Yeah.
And
otherwise, we can get back to you with some very specific numbers.
I think it's worth it to get a good order of magnitude number here. I will point out, Sudhanshu, that Hyperion in some ways has better access to data through talking to customers about what they're doing, because at Google, we of course are very privacy oriented. And so we never look, at what users are doing with their job that way. We can only infer it from various kinds of signals and things. But Hyperion talks directly to customers about it. So you've got the cloud spending market there at
15% to 60,000, but here's showing right now. So if we speak to 2024, the cloud spending was $9.5 billion roughly. We could say 10 billion, as a run rate at the moment, between the 24 and 25. And then we're seeing Google share right now, roughly at the 20%.
So roughly $2 billion.
Yep. So on the order of $2 billion right now.
Yes.
And I should be careful here too, as you mentioned the different methodologies and the way we calculate it. Our numbers are based on surveying lots of people. Each of the studies Jacqueline showed you had like 100-ish people in the survey. On a yearly basis, these are based on surveying thousands of people. As for what the spend rate is, we are nervous because we know there's some stuff that we're missing here. The U.S. military intelligence community and folks, they're spending money like you wouldn't believe. At a zero type, numbers right now. Same in the Chinese market. And that's why we say these tipping points, we're already aware of some massive spending that's taking place that aren't incorporated in our numbers, just because our methodology in that regard.
Great. Thank you, Earl.
Sure.
So there's another question here that is not really for Earl and Jackie, and I'm just going to repeat it because it will be addressed in upcoming sessions. Ogajan Tekin asked, what are GCP differences to support hybrid HPC spawning with popular HPC implementations? Ogajan, we'll be addressing that in a future Google Cloud Advanced Computing Community session, but that's not really a question for Hyperion as analysts. Although Earl and Jackie, I was very impressed to see how highly prioritized hybrid was for the users in your survey. So very interested to see that, and we will have more to say on that in a future Google Cloud Advanced Computing Community session. Let's move to another question here. Joshua has a great question, very relevant to the kinds of data that you presented. What long-term metrics will you use to measure the success of user-centric advanced computing platforms, time to insight, reproducible discoveries, or energy efficiency per scientific output? We might have our own metrics, but as analysts, are you going to have metrics for those kinds of things? So
in the last 10 years, we've done a lot of work, and I always have to thank the Department of Energy for funding our research on that, for the return on investment, which is a little bit more dollar-centric, but we also have a return on research metric. We are hoping to take this whole body of research to a new level, and we're expecting to get the funding anytime right now, so it'll be launching very soon. But what we really want to answer the question is, what's the value of doing research? What's the value of doing a training model? And so we've come up with 5 large categories, and there's like 10 subcategories to each of those. So the larger categories is scientific research and discovery. And then the next one is engineering work, to build better products, better cars and that. Another one is safety, as far as the healthcare, the weather forecasting, and so on. And the other one is very directly to help the economy, creating jobs, creating dollars for the economy and everything. And then the 5th one is national security. But, this gets tricky because, how do you say discovering something new, discovering how fast a black hole spins? What's the value of that to the world? And that's the work we're actually doing is, we're putting a stake in the ground to say that if you discover something new, and we have a 1 to 10 scale, on those different parameters. And I also want to thank Recon and Nurse because they've helped us do 2 studies already where we've created a data structure. Our data structure has over 700 successful projects already, and it's ranked on these different scales. So that's what we're planning to do going forward, is we want to really show what the end value of doing all this is. At the same time, a lot of the charts Jacqueline was showing is Jacqueline's working on a total cost of ownership model. What is the real cost of using a cloud? And again, some of the metrics have to be softer metrics. Getting an answer faster. What's the value of that? Well, again, you come up with a scale and then you start working and you talk to a lot of people. It's not perfect, but we're doing things like that. But Jay, the one that I'm really struggling with is when NVIDIA and AMD said, we're going to have a new processor every 12 months. And the cost of these machines are getting gigantic, as you know. And so you have to keep them longer if you buy them on-prem. So it's not a 3-year purchase. It's not a 4-year purchase. In many cases, it's a 5-year purchase. So how does a site deal with new technology every 12 months when your purchase plan, you have to keep the machine for 5 years? I think that's a fundamental problem that's going to take a lot of wrestling in the market. There's some solutions like, hey, maybe we only buy a little bit at a time. And some of the folks at the Office of Science have said, well, if you buy a little bit at a time, how can you be leadership? If you're going to be a leadership site, you really have to buy something large, right? So I think that's a fundamental problem. And again, I think that's where the clouder is going to have a big advantage.
Earl, I couldn't agree more. I think that's a tremendous advantage of the cloud. The faster the infrastructure evolves, the more advantageous it is to leverage a cloud purchasing agreement that allows you to change that spend to newer technologies in subsequent years. So huge advantage for clouds that at their scale are constantly deploying new technologies, as opposed to the singular system on-prem budget that, as you said, you've really got to amortize the life over 3, 4, 5, maybe more years. Another question from our audience, from Jose, asked if we can share the slides from this. Obviously, we're presenting them in this, and they're going to be in the YouTube video for this. But can we post these slides attached to our webpage so that people in the community can come download the slides?
Yes.
Great, thank you. Another question. This is another question from Jose, and it's a great question in light of your analyst roles. What about the cloud partner ecosystem? Which opportunities do you see in the professional services practices?
So I'll start, Jacqueline, and then if you don't mind adding. So first of all, Jacqueline mentioned that her advice to some of the cloud, to Google and the other cloud providers, got to make it easier to use the cloud. A lot of applications aren't cloud friendly yet. But let me add something to that. Most people don't know how to do AI right now. If you were asked somebody, what kind of AI are you going to do 3 years from now? Most sites have no idea what the models will be, what the hardware will be, or any part of it. And the desire to do a lot of AI is very high. The knowledge of what you're going to do is very low, especially I'm talking about long term. You may know what you're going to do in the next step. And I think professional services on getting on board on the cloud. But the biggest issue we have, and Jay, you've seen in our presentation for the last 4 years, the expertise in this industry are aging out, and we don't have a lot of young people coming into the HPC industry. So what you have is domain experts, scientists, engineers, people doing movies, people doing weather forecasting. They want to do their science. They're not interested in becoming computer experts. So they really need a lot more hand-holding. And quite frankly, I think that's where AI has a big advantage. I mean, a lot of people say, what jobs are going to be lost with AI? And they first say, help desks, as one example. But I'm just saying that that's a major thing where professional services can help as far as getting people onboarded, getting them up and running, getting them productive, but also helping them evolve, because I was saying, agentic AI, we weren't even talking about that 12 months ago. This is changing so fast.
Yeah, Earl, I appreciate everything in those answers. Jose, you might want to reach out to Adnan Khalil, who put his contact information in the chat window, if you are from a partner company. And Earl and Jackie both mentioned the need for better support services, maybe from the CSPs themselves, more comprehensive support, more fast evolving support that continues to make it easy for new people to get on board so we can train a new workforce in this and keep it up to date with the technologies that we're constantly rolling in. So very much appreciate that as well.
Yeah. And coming to it, like Earl said, these are domain scientists. They come so specializing into genomics. I mean, advance your genomics support. Say, yeah, we know everything about how to get your, a workload like yours into the cloud and running AI. These are what you can experiment. Having those platforms, having those frameworks for the those scientists. Again, they might not know anything about how to use AI. Show them what's possible. Show them, create those communities around domain-specific sciences.
Yes. Serban asked a question that might be a quick final question so I can make final announcements. He said, many thanks for the insights, very useful. Well, I do understand that China and some other markets cannot be covered. Is it possible to do a split in between the US, EMEA, and APAC? So Earl or Jackie, do you have just some really rough numbers of the split between US, EMEA, and APAC?
I do, but I don't have it handy.
Right, so I can say in real crude terms, the U.S. historically has been around 48% of the world market on this stuff. That number includes China, by the way, in that particular split. And then APAC has struggled to stay above 25%. There might be one year they're a little higher than that in rough terms. Many years ago, Japan was a sizable segment. Japan has not seen the same growth that the rest of the world has. So they're just included in our APAC numbers right now.
All right, great.
But if you send us that as a request, we'll send you and you can share it publicly, a whole data table, because as Jacqueline said,
yep,
we track it by 28 countries, all different types of regions, and whether you want just the cloud only or the on-prem plus the cloud, however you want it, we'd be glad to share that.
we're happy to help.